Hello, friends. 5.5 physics. There have been questions about 2b, 3, and 4b. This cord is in the way. All right, so let's have a look. 2b. First of all, 2a. I always have to know that. So, okay, a 65 kilogram student climbs 5 meters up a rope in a gym class, constant speed of 1.4. Determine the time it takes. Okay, so that's just probably a simple formula. What is the answer, though? Oops, I'll fix my camera. Just so I know. Well, actually, let me see what the question is asking. Determine the student's power without finding the time. Oh, okay. 2b. So you've got mass is 65. Displacement equals 5. Vi and Vf equal each other, which equals 1.4, which means acceleration equals 0. All right. I suppose, anyway, it would be 9.8 would be the applied acceleration. The net would be 0. So this is just power equals E over T, E being mgh. So that would be A. But B says, determine the student's power without finding the time it takes, without finding time. So E equals mgh. It also equals force, which equals, work, which equals force times distance. Force is mass times acceleration. Acceleration 0. Oh, constant speed. Okay, so if it's a constant speed, then you can figure it out for 1 second. In 1.4 meters per second, in 1 second, the displacement would be 1.4. So in 1 second, power equals mgh over 1 with just 1 second. And so the h would be 1.4. And then you would multiply that by 5. You dig? Questions like that, 2b, that's not the type of question I would ask you, nor is it the type of question I would expect from you. Now, having said that, if you wanted to do that, that's great. But it is a little bit above and beyond, so don't sweat it. Number 3, that was tricky. I had to think about that. Number 3, a student uses a pulley to lift a mass into the air. Assume the mass is lifted at a constant speed, so acceleration is 0. Vi and Vf equal each other. Describe one way you could determine the power of the student when she is lifting the mass. Describe one way. Well, you could do it the normal way. Okay, P equals work or energy over time. That's one way to do it. B says, that was A. Assume the mass started from rest to ground and accelerated upward with constant acceleration. What types of energy will the object have while it is being pulled up by the student? How would you determine the student's power in this case? Okay, so the total energy is all the energy in the system. So that's EK plus EG. EK is kinetic, EG is gravitational potential. As this thing goes up, I'll call this like position 1, position 2, position 3, position 4. As it goes higher, the mgh, the gravitational potential energy, that increases. The kinetic energy, if that is increasing, because the acceleration is constant, it doesn't say 0 though. Accelerate upward with a constant acceleration. It's going to be moving, put it that way. So it's, 1/2 mv squared. So at each of these points, you will have like EK plus EG. So if the speed changes, it says constant acceleration. If acceleration is 0, then it doesn't change. So this one wouldn't change. If it's constantly going up, then this changes every time as well. Potential changes every time as well, because each time it gets higher, there's more potential energy. Just think about if it falls harder from the higher height. Does that make sense? I feel like I'm going too fast. It's tricky not having you guys there to get the instant feedback. If that's an issue, let me know. I think that's straightforward, but like I said, if it's an issue, let me know. 4B. Excuse me. Oh, now I'll say it later. Wait. Wait, tomorrow. Well, I'll say it now for anybody listening, and hopefully I remember to make a written note of it. Tomorrow, there's nothing new. Nothing is assigned. It's kind of a catch-up day. It's a figure things out day. It's correct mistakes day, things like that. There will be nothing tomorrow except kind of optional discussion, because I saw that you guys said you didn't like my outcomes there. It wasn't enough specificity. So I'm going to give more info on that, and I'll post that in a little bit. And it's up to you. You don't have to check in with me at all tomorrow, okay? I just want to be clear. Also, Friday, Wednesday and Friday, no class. Friday is report card prep. So it's no school. No school where you are, no school regular or anything. Teachers are going to be busy with report cards. So you got nothing to worry about Wednesday, Friday. Not from me. I'm assuming your other teachers are the same. All right, 4B. I guess look at 4A first. Family 5 is planning to install solar panels on the roof of their home to help reduce the cost of electricity and save energy to help the environment. Family plans to install 10 panels, each with a power rating of 600 watts. Notice that says 600 watts, not kilowatts. That would be 0.6 kilowatts. On average, a solar panel can produce electricity. Was that a wheezing sound? Are you laughing?
I'm laughing.
Oh. Sorry, guys. My wife followed me to work today. 0.6 kilowatts. On average, a solar panel can produce electricity for 0.5 hours a day. A, how much solar energy will solar panels transform into electrical energy each day? For A, 27 kilowatt hours. Okay. So A is 27 kilowatt hours. B is saying, assume the average cost of electricity of 5.5 cents per kilowatt hour. 5.5 cents, which is $0.055 per kilowatt hour. How much money will the family save a year on their electrical energy bill? Well, if you have 27 kilowatt hours, right? 27 kilowatt hours. Multiply that by the cost, 0.055. So this would be the cost per day. But this is for, how long is it? A week? A year. Excuse me, 365. If you want to be real smart, you can say 0.25. 365 days a year. 27 times 0.055 times 365, 0.25, because, you know, we're real smart. 542. So with sig figs, $540. That's what they're saving. I'll just double check my answer. Yep, 540. I'm curious if that 0.25 made a difference. I doubt it. 27 times 0.055 times 365. No, it didn't. All right. There's your answers. Hopefully that makes sense. Let me know if it don't.